actually featuring expert judges. So people know who is the that's how we people know.
What's his name? Swarnendu.
So Swarnendu Ghosh. First and second people are the presenters.
Hmm?
And the first and second presenter.
They are.
So if everyone join and take some of the numbers, the chat will do. And so while speaking, give me a sense so that I can mic focus the voice control. Before you speak, I give me a signal so that I can mute the mic. Otherwise, they go.
Wait. Letting the sound.
Yes, but while afterwards,
But why the mic is located?
then also,
Okay, it's not audible. Let's keep talking. It's not audible.
like afterwards, I'm going to speak. Because when once I
What's his name? Swarnendu. Cosa? Halo? Situ mereka itu dia oke join করছে না ধরি ডক্টর সন্দেহ নাকি তুই জয়েন করে আমি আছি হ্যাঁ আমি ঘরেই আছি
only go live all the time.
ইয়ে
Actually,
কথা
if you go live
Hello. Hello. ঢুকেছি। Hello. 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 Hello.
Yes, sir.
Am I audible?
Yes, sir.
Okay. Um,
A very good afternoon to everyone. We will now proceed to our next session. We please welcome our chairman for this afternoon, Dr. Arnab Kumar Maji and Dr. Swarnendu Ghosh. Dr. Arnab Kumar Maji is the associate professor in the Department of Information Technology, Northeastern Hill University, Shillong. He has published more than 32 number of articles in different reputed index journal, around 50 number of articles as book chapters and conference proceedings. Also edited 3 books with reputable publishers like Springer. He has published 2 Indian patent and filed 1 patent. His research interest includes machine learning and its application domain like image processing and natural language processing. He is a senior member of the IEEE, EC member of the IEEE Guwahati subsection, and has active collaboration with several reputed Indian and foreign institutes. Dr. Swarnendu Ghosh is an associate professor at the Department of Artificial Intelligence and Machine Learning at IEM Kolkata. He has completed his PhD from Jadavpur University in the field of deep learning and computer vision. He is also an Erasmus Mundus Fellow from the University of Evora. Dr. Ghosh has made several contributions in the field of deep learning via multiple repeated journals, conferences, and publications, books, and has been recently working on deep learning applications and machine imaging. I now welcome Dr. Arnab Kumar Maji and Dr. Swarnendu Ghosh to chair this session.
So thank you very much. Dr. Ghosh, am I audible?
yes, you're perfectly audible.
Okay. So let us start the technical session number 6. And in these sessions, I think we have 9 papers. So the first paper is paper ID 25. It is lesion image segmentation for skin cancer detection using pix-to-pix a deep learning approach. Okay. So I request the presenter to kindly proceed. And you will get only 10 minutes for presentations and 5 minutes for interaction. So please maintain the
Yeah,
schedule.
thank you. Am I audible? Hello?
Yes, you're audible. Yes, yes.
Thank you. Just a minute. Let me share my screen. Is it visible now? Hello?
Yes, it is visible.
Thank you.
Check.
Good afternoon, everyone. I am Dr. Shomik Bhaumik. Assistant Professor, Department of Computer Science and Engineering, Gonikan Chaudhary, Institute of Engineering and Technology, Malda. Today I'm here to present our work, Lesion Image Segmentation for Skin Cancer Detection using Pix-to-Pix Deep Learning approach. It is basically a final year project of my students Nimai Roy, Achishman Kundu, Pritiman Sikdar. During this presentation, first, I will say a little bit about skin cancer and explain the reason behind considering this problem for our work. I will explain the proposed method, experimental results will be presented, and finally, I will conclude the presentation. So, just like other cancer, abnormal growth of skin cells causes skin cancer. There are multiple reasons behind that, but most common reasons are growing age, effect of ultraviolet rays on the skin, and application of harmful chemicals. Although these are not the only reasons, there are multiple other reasons. Skin lesion is basically a part of the skin that has an abnormal growth either or a abnormal appearance in compared to the surrounding skin region. There is a sample image for our understanding is given in figure 1, that is a skin lesion image. Most of the skin lesions are harmless, but there is a chance there are some skin lesions that can be malignant or that has a potential that can evolve into skin cancer. So malignant skin lesions are basically skin cancer. Now there are basic few symptoms like persistent skin lesions that does not heal with time. There is a that can be serious. So this is what about skin lesions is. Skin cancer are found to be very common with the fair skin people, and estimate as per some estimation around 50% people with fair skin complexion live up to 65 years will grow at least one type of skin cancer. So it shows that how common it is. As per a global cancer statistics 2020, 11 lakhs 98,073 new cases were reported, that is non-melanoma skin cancer. And out of that, 63,731 death cases were there. Due to melanoma, there was 3,24,635 cases were reported. 57,000 death cases, 43 death cases were reported. So the number is really big. So this is a crucial problem that need to be taken care of. But the good news is that if it is diagnosed or caught in the early stage, the skin cancer is highly treatable. Therefore, the early detection of the skin cancer is necessary. To develop a computer-aided diagnosis system to do that, this is our reason to consider this problem. And in the present scope of the work, we have focused on segmentation of the skin lesions to identify the region boundary or the region boundary of the infected area. So in the proposed work, first I will explain the challenges. There are multiple challenges in way of segmenting the skin lesions. First is basically the huge color variations. There are multiple reasons for that, for these color variations. The texture of the skin, complexion, even the presence of body hair, these basically acts as an artifacts, and that pose a challenge for a segmentation method. That's why in the literature, most of the early methods they actually focused on the pre-processing modes to remove this. But later, when the deep learning methods have came into the picture, they mostly focus on the model based. So in the present scope of the work, we have developed a generative adversarial network based model, that is Pix to Pix, to segment the skin lesion images. This is the architecture of our model. This is generally, we all know that a generative adversarial network has two module, that is the generator module and the discriminator module. The architecture of the generator module includes 8 encoding and decoding layers. Input, the every encoding layer consists of convolution layer, batch normalization, ReLU activation, and the first encoding layer basically accept a 256 cross 256 cross 3 image, which is 256 cross 256. It is basically height and width, and 3 refers to the channel. So last encoding layer generates a vector of 1 cross 1 and 512. Then it is sent to the decoding layers. Each decoding layer contains deconvolution layer, batch normalization, and ReLU activation. The decoding layers finally produce an image of 256 cross 256 cross 3. At the intermediate layers, we have used dropout to avoid overfitting. That is a huge problem with deep learning models. So dropout is considered. So at the discriminator architecture, 5 encoding layers were there. It takes generator output and the ground truth as input. It produces a vector consisting of zeros and one that indicates the input was fake or real. This is the objective function. It has two parts, that is the LC and L1. The L1 function is described in equation 2, equation 3, and LC is given in equation 2. This is the objective function for our model. And at the experimental section, we evaluate the performance of this model on the basis of ICDEC-2016 dataset. It is International Skin Imaging Collaboration. They have multiple dataset, but we have used a 2016 datasets, which has 900 dermoscopic images for of skin lesions as training dataset, 379 images as test dataset. Some sample images from these datasets are given in figure 3. We see that there is the raw image and corresponding ground truth of this segmentation result. So there is a training parameter for optimizing. For the optimization of our model, we use Adam optimizer. 150 epochs where their lambda value was 100 and learning rate was 0.0001. For the evaluation, some standard matrices are used: specificity, sensitivity, dice coefficient, Jaccard index, and accuracy. Here TN reflects true negative, FP reflects false positive, TP reflects true positive. So FN reflects false negative. So these are the experimental results, and it is compared with some standard methods. From the table, it can be observed that none of these methods, all these are recent methods, so none of these methods have acquired best result in all 5 parameters. There are different methods have obtained best result in different parameters. Our results are bit comparable with them. The major issue with the deep learning model is that they need hardware resources and more explore that means variation of this model and various parameters is also required to achieve better result. So the result with the present model is quite comparable with the existing results. So this is the image level comparison, the original image, raw image, and corresponding ground truth, and the output generated by our model is given in the last row, and which is a bit closer to the ground truth given. And now finally we are at the conclusion. So skin cancer is commonly diagnosed cancer. It is highly treatable, as I said, if it is detected at the early stage. Therefore, it is necessary to develop a computer-aided early detection method. So to address this problem, we have developed a GAN-based method to segment the skin lesion images. And to evaluate this method, we have used ISIC 2016 dataset, and where this method has achieved 93.95% accuracy. So after segmentation, classification is also necessary. So in future, we have planned to develop classification module, and we will further explore the performance of the present model in different other standard datasets like ISA 2017, PH2. All these are standard datasets where in future we are going to explore the performance of the developed methods. And these are few references. Thank you. If you have any question, please.
So, thank you so much. Yeah. So, I would like to ask any questions.
Hello. Hello, my audible?
Yes, please.
I was curious to know if are there any samples or images where there are some wrong classifications, or maybe because I saw the recall was specificity was quite was lower than the others in some cases. Are there any wrong sample images or
Sample images, actually, currently it is not present in my slide, but still I can explain here. Is it the slide, is it visible that I'm showing? Yeah.
yeah, yes, yes,
See,
yes.
yes, if we see the output of our method, there is some pixel level differences. This is the ground truth. For an example, if I consider this image, uh, consider this one. So we can see the black pixels, and here the deficiency. So that basically the pixel level misclassification basically contributing here much in all the results. Here also we can see this is the ground truth, and the number of pixels, these are very smooth, and there we have some roughness in the boundary area, and that means there is some misclassification of pixels either as black, either as background or foreground. So that basically contributing, I guess, in the parameter different matrices.
Okay. As extension of this paper for future works, you might want to compare with other types of maybe UNet or SIGNet or things like that.
Sure, sure.
That will
Thank you.
boost the quality. Thank you. Nothing from me.
This one. Huh. Hello. Can you hear me?
Yes, yes.
Okay, 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 man. It's a good presentation. So I just would like to know that why you have done this deep learning, chosen deep learning based technique for image segmentation. Other segmentation techniques are also there.
Yes, there are multiple segmentation techniques, but deep learning based model, basically the reason behind considering generative adversarial network, there are multiple works that is available in the literature. They have considered convolution neural network, and it can be observed that convolutional neural networks have been obtaining much better result in compare with the traditional methods. And in paper that is there is a proof. And but why we have chosen generative adversarial network? Because generative adversarial network, specifically this variant pix to pix, considered this segmentation process as a image to image translation. So in translation process, in case of CNN, generally if we want to perform some specific work with CNN, it is better to design, that is it requires to design a good objective function or loss function. So in that case it depends on how good loss function we are building. But in case of generative adversarial network, it not only learns a loss function, as well as it learns the loss function in terms of mapping from one domain to another domain. So that is this is what basically motivate us to use generative adversarial network over traditional CNN actually.
Okay, and just I would like to know another things. That is, what about the data set? From where you collected this data set?
Actually, they have a website, ISIC International Skin Imaging Collaboration. They have a website there. They made all the data sets available, and from their website we have downloaded this data set.
Okay, thank you very much. And
Thank you.
is there any questions from the audience? If there is no questions, so let us thank the speaker for his presentation. So thank you.
Thank you. Thank you.
So we may move to the next presentation, which is paper ID 47, an approach towards detection of doubling print defect using SSIM algorithm. So the presenter maybe start sharing his presentation. Okay, mute it.
Okay, sir. Sir, am I audible? Hello.
It's audible.
Yes, yes,
Uh,
audible.
okay, sir. I'm sharing my screen. Just a minute. Sir, is it visible?
Yes, I think so.
Okay, so can I start?
Yeah, proceed.
Okay, so good afternoon, everyone. Let me allow to introduce myself first. Myself, Joita Shah, Research Fellow of the Department of Printing Engineering, Jadavpur University. Today, I am going to present a paper titled as An Approach Towards Detection of Doubling Print Defect Using SSIM Algorithm. My co-author is Shilpi Nashkar from Jadavpur University. So first of all, we need to understand what is actually doubling print defect is. In offset printing lithography process, a faint duplicate impression occurs with the actual printed image. Then this defect is termed as doubling. It is a very common print defect where non-directional extra image is created. As you can see in the image, sample image, the number 10 is printed twice, or in the text image a faint duplicate impression is there. And in this context, I want to notice your attention that this actual image's intensity is higher than the faint duplicate one. So this kind of defect is not acceptable and can be resolved by cleaning the blanket or changing the ink grade or changing the paper grade. Generally, in printing press, this kind of defect is detected manually. This manual detection procedure depends on the ability of a person and varies from man to man. So, the main objective of our work is to make the detection procedure less manual intervention. So, an approach is made with the computer vision based technique for the doubling defect detection to make this procedure detection procedure less manual intervention. Okay, so for further going to the detection process, first of all, let us know what are the causes and the effect of doubling. When ink transferred from previous sheet to the next sheet through blanket, if the ink transfer, there causes a doubling print defect. If the printing blankets are not cleared properly or not packed properly, or there are some misalignment of drive gears, it can causes doubling. Moreover, in our printing, the substrate is celluloid in nature. So, due to moisture absorption, there must be some swelling, shrinkage, as it is the dimension changes is there. So, this can cause the doubling print defect. As a result, the effect there are some non-directional faint duplicate impression is created, which in terms affect the print quality in terms of readability or archival process through scanning and OCR. To some extent, in our printing industry, dot is accepted, but when the halftone dots are printed with tiny shadow, this is not acceptable in any way. So qualitative identification of doubling becomes challenging to discarding the manual intervention. Okay, so these are some related works done in the field of computer vision algorithm like SSIM, which we have chosen for this research work. Like SSIM is applied to detect the print defect on metal container, on print circuit board, or the structural similarity measurement, that is SSIM is used to retrieval of images, and some scumming print defect is identified using computer vision method. But as of now, most of the quality evaluations in printing processes are subjective and manual. There are not that much well reported technique in computer vision based into this field. So this makes our approach a little bit of challenging to us. Okay, so these are our proposed methodology, the flowchart of our proposed methodology. So at first, what we have done, at first we take the digital copy of samples, which are mostly collected from various printing presses by using mobile camera only. Then the RGB image of these samples are converted to the gray color space. Okay, so as we know that the gray color space is device independent, unlike RGB color space, so that the result of gray color space doesn't vary from device to device or manufacturer to manufacturer. Moreover, for the ease of the work, to apply some image processing algorithm like smoothing, sharpening, segmentation, it is easy to work with a single color value channel rather than three color value channel. Okay, then in the next step we have computed the connected components. So to understand the connected components, we are moving I'm moving to the next slide. So the here you can see the connectivity of pixel can be computed in many ways, like there are 4 connectivity, 8 connectivity, n connectivity. As you can see, in 4 connectivity, the same intensity of pixels are connected horizontally or vertically, and in 8 connectivity, the diagonal pixels are also considered. So if we consider the image as a matrix form, this connected pixel can create a region. Okay, so in our work, 8 connectivity of pixel is considered. Generally, in doubling print defect, as a duplicate image is created with the actual print image, there are some overlap region with distinct one. So pixel connectivity helps to detect those regions, and based on that, segmentation and other image processing algorithm is performed. So back to the flow chart. Sorry, back to the flow chart. After computation of level connected components, we have done thresholding. Here, adaptive thresholding has been performed to segment the foreground and background image, but only thresholding operations are not enough to segment the image. For that purpose, some morphological and logical operations are also done. And in next step, by using pre-weight edge detection operator, the edge of the actual print image and duplicate image is detected. So to understand better, the pictorial view is here for our experimental result. This is the text based image for sample 1 and sample 2, and this is the image based image, where you can see this is the actual image where doubling occurs. First of all, we have converted into the grayscale image. Then we have detected the foreground image based on the connected pixel, and some by applying some thresholding and logical and morphological operation. And then we have detected the edge of the printed and duplicate image. And from there, we have cropped the region of interest where the same edge is repeated. Okay, so this area of interest is cropped. Okay, to check the similarity between the edges and the pattern. Okay, so back to the flowchart. After edge detection, we cropped the region of interest. Then we applied some printing quality evaluation method, that is SSIM algorithm. So to prove the effectiveness of SSIM algorithm, that is structure similarity indexing method, we have also applied some other quality evaluations method like MACE and FSIM. Generally, MACE is gives the that is mean square error method, that gives the measurement of error between the images, that is the absolute error. The error is basically the average of squared error pixel by pixel to all over the images. So the value closer to 0 is considered to be the better result. On the other hand, FSIM stresses only to the feature of images in frequency domain. So this feature in FSIM, this FSIM is invariant to contrast and luminance, where in our printing defect, it is very much important to consider the contrast and luminance condition, because if the luminance and contrast varies, the result may be vary. So in SSIM, these two conditions with the structural correlation is considered. So SSIM helps to detect the similarity comparing these three conditions like luminance distortion, contrast distortion, and loss of structure correlation. Okay, So we prefer SSIM over FSIM and MSE. So to prove this, these are the results of samples from sample 1 and sample 2. This is the text-based image where SSIM result is there. It is proposed that if the similarity percentage is above or equal 90%, the two tested image is considered to be same. The two tested images pattern or edges is considered to be same. In case of text image, that is sample 1 and sample 2, we can see the structural similarity is above 95%. But in case of the image based image, that is sample 3 and sample 4, there are less accuracy, because in case of a doubling defect, we have got some overlapped edges which is quite difficult to segregate in case of image based image. And here you can see FSIM supports the result of SSIM, but we have not considered it's more appropriate to detect the doubling print defect as it is invariant to contrast and luminance. Whereas the MSE does not support the fact and considered as only the absolute error between the crop region. Okay, so it can be concluded in a way that as in doubling defect, repeatability of same edges of printed pixel depends on contrast distortion, luminance distortion and structural similarity. So SSIM approach is considered more compatible in terms of doubling print defect detection. Moreover, as our whole detection procedure is totally done in MATLAB, it helps to make the detection procedure comparatively less manual intervention than the subjective measurement. Okay, moreover, we have used the mobile camera only to take the digital samples of the digital copies of the samples, so it makes the procedure less expensive. So these are the advantages of our proposed algorithm, but the limitations of not getting 100% similarity between the edge patterns of double printed samples, and in case of getting the less accuracy in case of image based image, it can be rectified by further post processing operations. Okay, so the future scope of our work can be the inclusion of artificial intelligence application. Moreover, as it is the approach is less manual intervention, it can be a mobile based application. So you know that mobile is available nowadays, which mobile is available to us. So you can make a mobile app to detect the print defect easily. Okay. Moreover, the furthermost future work is to the removal of double printed edges and reconstruction of images. So these are the references from I have taken help. Thank you, sir. Have a good day.
So thank you very much. So I just want to know. I think only you have tested with only 4 images.
No, sir. I have taken 150 samples. Here I am showing just 4 samples.
Why? That means you are telling that this algorithm performs better. Okay,
Yes.
but your sample shows that it's not always better. Sometimes it is as per. Okay, is there any mathematical proof or justification that this performs better? Mathematically, is it possible to prove?
Mathematically, I have already proven, I have shown the result, the percentage of similarity. I have shown that the SSIM values are above 95% in case of text based image. But yes, there are less accuracy in image based image, which I am working on. I think some post processing operations can be rectified. This problem.
So I want to Dr. Ghosh, can you please continue?
Yes, I would like to continue with the question that you have already asked. Like the metrics that are shown are sample specific. The one that was shown in the table. Is there any metrics for the entire data set? Like for all the 150 samples, what is your average percentage accuracy? Is that shown somewhere?
Yes, for 150 samples, I have preferred the SSIM only as because it gives better result than FSIM and MSE.
But that result, if it's shown somewhere, it's not shown in the presentation. Is
No,
it shown
it's
in the
only
paper?
for sample four. It's only about sample. I have shown the four samples here, but I have the data set actually.
Actually, the across the dataset, some performance average metrics should have been shown.
Okay.
Anyways, another question is the SSIM algorithm. What does it actually give you as output? Does it give you output whether two regions are similar or dissimilar?
Yes, it is region based. We have segmented region based that is based on the pixel connectivity, and we have checked the edge pattern actually. Okay, where the edges are similar or not.
Okay, so another thing that was missing, I think, was maybe an image where you can show which pair of boxes have been marked as similar. Maybe you can have a pair of red boxes, pair of green boxes, something like that, and show
Okay,
that
no,
these pairs have been.
I think, sir, I have shown in the pictorial representation. I have cropped the region of same age, repeating the same age, and from there I have cropped that two images, and between that two images, I have checked the similarity.
Yes, but after checking which is
Hmm.
marked as similar and which is marked as dissimilar, after the checking
Okay,
is
okay, okay,
that
okay,
image
sir.
is missing. Okay,
Okay,
the
okay. I'll
final
keep
output.
it in mind. Okay, sir.
Please proceed.
Okay, sir.
Proceed, sir.
Thank you, sir.
Okay. Is there any question from the audience? Is there any questions? If there is no questions, we can move to the next speaker. Let me thank, Dr. Jaita. Okay, so our next presenter is paper number 92, an applications of anomaly detection of financial fraud using machine learning. I want to invite the next speaker, who is okay. So Mr. Okoro, you can please start your presentation.
Good afternoon. Am I audible?
Good afternoon. Good afternoon.
Okay. Let me share my screen. So, is my screen visible? Good afternoon.
Good afternoon. Good afternoon. Please proceed.
Okay. Yeah, so my name is Udochukwu Okoro, and I am going to present a paper titled An Application of Anomaly Detection to Financial Fraud Using Machine Learning. I'm a student of the American University of Nigeria, and my co-authors are Usman Baba and Dr. Sandeep Rakshit. So we're going to explore the introduction, then we're going to review the literature of the paper, the literature that we reviewed to write the paper, and we're going to look at the methodology methodology that set us up for our findings. We're going to look at how we source data and presentation. We're going to explore algorithms such as vector
So,
machines,
sorry for the interruption.
logistic
Can you
regression.
make it full screen, Mr. Okoro? Can you make it full screen? Can you make the
Oh, I
presentation full
thought
screen?
I did that. Sorry. Oh, let me do that.
Yes, just make it full.
Or maybe you can turn on the slideshow.
Is it
Yes. Turn on the
is it better
slideshow.
now?
Slideshow.
Okay. Is it better now? The slideshow is turned on. Is it visible now? Or it's not?
Yeah, I can see the entire PowerPoint application. Please turn on the slideshow.
Okay.
Maybe it will help.
So now is it centered? It's on. Okay. Let me redo it again. I think there's an error. Let me do it again.
I think you can press F5 most probably to, to make it full screen actually after going to the presentations. Yes, yes, that's fine now. That's fine. Please,
Okay.
please
Okay.
move on.
Thank you.
Thank
Okay.
you very much.
Okay.
Please
So
move on.
yeah. So we're going to look at the metrics, results, and conclusions and recommendations. So the pandemic really affected the financial space, and we moved to a lot of card not present transactions, because card not present transactions are those transactions in which we do without the use of our ATM or bank cards, and these transactions are more prone to fraudulent practice, because of the fact that they do not require the physical presence of a bank card. So that was the motivation for this paper, and we intended to highlight a classification algorithm that was able to predict and classify financial fraudulent transactions with a focus on card not present transactions efficiently. So we reviewed some literature, such as a paper by Roy et al. In 2021 that explored the detection of credit card fraud with various classification algorithms such as isolation forest, support vector machine, and logistic regression. Dankard et al. Also utilized logistic regression, random forest, and XGB classifiers to classify fraudulent and non-fraudulent card transactions. Chen et al. Also conducted a study in 2020 that focused on modeling anti-fraud technology with the use of machine learning techniques. So we sourced our data. Our data was a data set. It was a financially synthetically generated data set. It was a synthetically generated financial data set, and so this means it was generated artificially, and this is because financial data is generally very private and hidden. So um, for initial exploration and modeling, usually synthetic data sets are used because they also accurately to some extent represent the nature of real-time financial data. So this was what was used. It was sourced from Cargo, and we cleaned data sets, and at the end we had features such as the type of transaction, the amount of money transacted, the old balance of the origin and destination accounts, the resulting balance of the origin and destination accounts too. And these features were important in developing a holistic model that will be able to predict classification, and I'll be able to predict whether a transaction was fraudulent or not fraudulent. And as you can see by the chart below, there is a high variance between the fraudulent cases and the non-fraudulent cases, because in the real time, the fraudulent cases are represented by 1 and the non-fraudulent are represented by 0. In real time, this is how it is. Not fraudulent transactions are more than fraudulent transactions. So we use support vector machine, and this is a very important algorithm that tries to basically, the whole concept is with something called a hyperplane, and a hyperplane is a line that tries to separate the two data points as much as possible, and the whole point is to have the 2 points closest to the 2 data points closest to this hyperplane to be as separate as possible, to be as far as possible from each other. So when we have them as far as possible from each other, we are said to have an optimal hyperplane. So this is one algorithm we used, support vector machine. We also use logistic regression, which is very good which is used for binary classification, where we have just 1 and 0, where you have yes or no, or yes and or active or not active. So this is where we use this to it predicts probability that a data point falls into a categorically dependent variable when it is binary. And we use Gaussian naive Bayes too, which is a very popular algorithm that works on the assumption that the features of the data set are independent. So it basically tries to determine whether an event has already occurred, and all the features of the class have to be independent. So this is the formula below for that. Then we use 3 metrics for evaluation. We use the accuracy metric, which was important in determining the percentage of correctness of the model. The precision metric too was also used in determining the preciseness of the model. And the recall metric was used to calculate how many true positives have been identified by the model. So now this is a confusion matrix for all the three confusion matrix for the three models that we used. And as we can see here, the confusion matrix for SVM give us one true negative and one true positive. And most of the, as you can see, that we had about most of a very high percentage of our results were false negatives. So it shows that this algorithm was, very efficient in doing this task. But here we can see that we have four false positives, and the rest of the results are false negatives. So we can see that here too, although there's some false positives, we can see that yes, it will also classify most of the data points accurately. And here we can see that there is a false negative. There's a false negative of about most of the. You can see that there's a true negative of two data points, and the rest are false negatives, such as just like the others. So we can see that there's a distribution of how the errors, because these are errors. Everything is supposed to be false negative, but we can see that there's a distribution of how the classification occurred. All data sets give us all the algorithms that we use give us different points, like different false negatives, true positives, and true negative values. And so this is a table representing what I was saying holistically. We can see that there's a 99% accuracy for logistic regression and 98% for naive Bayes, 99.5 for support vector machine, and a recall of 0.0, precision of 0.0 for logistic regression, recall of 0.0, and same thing with naive Bayes. But support vector machine has a recall of 1 and a precision of 0.5. So we can see that support vector machine is the only algorithm in this instance that actually has recall and precision values. Then so in conclusion, we were able to identify that support vector machine was, in this situation with the use of this data, was the most efficient algorithm for classifying this data. And as it worked, it had the highest accuracy, and generally was very effective in classifying when we paired it with data to develop a model. And in the future, I recommend that future studies use generated data sets from financial institutions, as there should be some form of access to this data for preliminary research, and the exploration of deep learning techniques can also be used in collaboration with this data set to develop another holistic model that will see how so that we can compare and contrast and see how the findings that we get. Thank you.
Thank you, Mr. Okoro, for the presentations. So, I just would like to know why you have chosen only the SVM only. Is there any particular reason except the accuracy, whatever you are claiming?
Yeah, we chose the SVM because also, apart from the accuracy wasn't the only metric, but we chose the SVM because it had true negative values that were, when you have a true negative in a financial data set, it is better than having a false positive, because a true negative means that it identified it as fraudulent, whereas it was not fraudulent. So it's better we have that than identifying something as fraudulent. Sorry, am I okay? It's better we have.
Can you just
So
get back to your slides?
Yes, okay.
Can you just get back to your slides?
Okay.
Hello. Okay. Yeah. Yeah. Okay. Just go back in the very first objective, I think. Yes, yes. After the introduction, right. Somewhere you are mentioning about the data cleaning part. I think I have seen
Yes,
somewhere the
yes,
data cleaning part. So how you have
yes.
done this data cleaning?
We did data cleaning by filling the missing values. There were some missing values in data set, so we did that. We filled in the missing values, and we essentially removed the features that we did not need in data set. So there were some features, there were some values that, sorry, I think there's some distortion, but there were some values
And
that were so- there's some distortion. I can't really hear what you're asking me.
okay,
But there
and
were some,
what about this?
okay.
I just want to know what about this this validation part? How you have done the validation?
The validation was done by finding the metrics after calculating the after generating the model. We found metrics such as accuracy, precision, and recall. So that was the validation that we did. That was the evaluation that we did using these three metrics. So we used the precision metric to find the preciseness of the model, and the recall metric to find the true positives, how many true positives we had in the model. And I was answering the question that was asked why I know that support vector machine is the most efficient, and it's because in a financial fraudulent data set, when you have a true positive, a true negative, it is better than having a false negative, because that means that you've identified a transaction that you falsely flagged the transaction, which is better than not flagging a transaction, a fraudulent transaction, not flagging a fraudulent transaction at all.
Thank you, Dr. Ghosh. Please continue, sir.
I just wanted to know about when you are running the SVM, how many features were present in the input data?
The SVM, how many features of data set do we use?
Yes, how many features?
Yes, we had, if you see in this slide, we had features such as the type of transaction, the amount of money transacted, the old balance of the destination account, the old balance of the origin account, the resulting balances of both accounts. So we had about, that will give us that will give us, I think we had about 8 features
Eight
of data sets
features.
that we use. Yes.
Did you run any other algorithm other than SVM?
Yes, we ran logistic regression and naive Bayes,
Logistic
Gaussian
regression.
naive Bayes. Yes. So these are the results that we displayed here. We ran logistic regression and naive Bayes as well.
Okay, thank you.
Is there any questions from the audience? No questions. Okay. So thank you very much, Mr. Okero. Thank you
Thank you. Thank you.
for the nice presentations. So now we should move on to the next presentation. This is paper ID 103, PAPNet, a patch-based multi-scale deep learning framework for nucleus segmentation from PAP smear images. So the presenter, I think this is Vijayini Bagchi. So please continue with your presentation.
I don't think you are audible. Yes.
Yes, I think she is not audible.
Uh, Very low sound is coming. The volume, the microphone volume is low.
Yes, unmute it. Unmute your microphone. Miss Bakshi, please unmute your microphone.
Yes, sir. Can you hear me now?
Now I think we can hear you.
Thank you, sir.
Please,
Actually, there was some problem. So, can you see the
please,
presentation? Is it visible?
please share your screen. I think it will be.
Yes, sir. I'm sharing my screen once again. I've already did it.
Yes. Now it's visible.
Is
Please.
it visible? No. Okay.
Yes.
Thank you.
Please.
So, can I start, sir? Yes. First of all, I would like to say that I'm Bijoyini Bagchi, belonging to Department of CSE from Brainware University. Is it audible? Hello?
It's
Hello?
audible. It's audible.
Yes,
Please
yes.
proceed.
Thank you. No problem. Sir, actually, I'm greatly thankful to my corresponding author, Professor Devotosh Bhattacharya, sir, as well as Mrs. Kaushiki Roy, for helping me to write this paper. So, just I'm trying to this is my first presentation. So, one thing I would like to say is that we actually presented this paper twice. So first it was on 11th August we first presented the paper, but at that time when the acceptance came, there was no plagiarism attached with it. So we thought that the plagiarism was below 15%, and so we submitted the camera ready version. But after some few days, then the plagiarism report suddenly came, and it was found out that the indexing was 28%. So we made the necessity changes and resubmitted the manuscript again on 23rd August. So it is my request to you that please consider our final resubmission or the second submission, that is on 23rd August. So it will be possible, sir. I think
This
because
Ms.
yes,
Baji,
sir.
I don't think this is the platform for that. You
So
must
the thing
contact
is
the
that this
judge.
is related to conference
Okay,
organization part. So we are
okay. So
only entitled to see the presentations and this thing. But
okay,
obviously
okay.
your concern will convey. Okay,
Yes, sir.
that's it.
Thank you, sir. Because my
Thank you.
author told me to convey this thing, that's why. Okay, thank you, sir. So first, actually, this the topic is actually a patch-based multi-scale deep learning framework for nuclear segmentation from Pap smear images. So first of all, we had done this on. I would describe the background theory and method, experimental results, and conclusion. And in the background, actually, first we need to know that what is the statistics of cervical cancer. So cervical cancer is actually nowadays a very popular thing which is happening in women. So it is actually mainly caused that it is linked with many various causes. So almost all the cervical cancer cases, 99% are linked to
So,
infection with high risk human papilloma viruses, HPV. And there are also cervical cancer is the fourth most common cancer in women. In 2018, an estimated 5,70,000 women were diagnosed with cervical cancer worldwide, and about
I,
3,11,000
I'm
women.
sorry to interrupt you,
Yes,
Miss
sir.
Bakshi. I think
Yes, sir.
the slides. I think is it the outline you are showing now?
Yes, sir. No. I'm just started the statistics of cervical cancer. Outline slide I've already shown.
Okay,
Now
okay.
I've started statistics of cervical cancer. I
Actually
was
it's not changing. Actually, it's showing still
okay,
outline.
okay, okay,
There
okay.
might be
Oh,
some
sorry.
delay or something.
Yes, sir. Now is it clear? Okay,
Yes,
thank
yes,
you,
Yes,
now
sir.
it is.
yes.
Yes.
Okay, okay.
So,
Please move on.
yes, sir. Almost all the cervical cancer cases, they are actually 99% linked with one virus which is called papilloma virus, HVP. Okay. And cervical cancer nowadays is the fourth most common cancer in women. And in 2018, an estimated 5,70,000 women were diagnosed with cervical cancer worldwide, and about 3,11,000 women died from the disease. So our actually my the work which we had done is we will extract some cervical cancer we will extract some tissues from the cervix, and then based on pap smearing test we will detect the nucleus, we will do the cell segmentation. This is actually our proposed work. So there are different modalities actually for cervical cancer detection. The first one which I've described right now, that is the pap test. And then there are other modalities also like human papillomavirus test, colposcopy, biopsy, etc., X-ray, then CT scan. Means there are many ways, but we will be focusing on the pap test. So challenges in segmentation of overlapping cervical cells. So what happens is actually in segmentation of the cells actually they are not clearly visible. Means like if you want to, for example, if I want to segment the cells, the nucleus and the cytoplasm, they are sometimes so much overlapping that it is not possible for humans, not possible by normal means to segment the nucleus from the cytoplasm. Also there are some other factors also like the cytoplasm and the background means they may also sometimes merge, and so at that time also nucleus detection becomes difficult. And there are other reasons also, like blood, then mucus, inflammatory substances. They also sometimes means get inside the cells, which makes actually a little bit difficult to segment the cells properly. So this pap test will means remove some of the shortcomings, and still we means there is work carried out still. And then this nucleus segmentation. So first, how do we do it? That we will have the input image, and then we will extract some patch from the image, and then there will be data set augmentation, and then the result will be fed to the proposed PBC, and then we will get the output. Output means we can detect the nucleus properly of the affected cells. So this is our PAPNet architecture. So we have the input image over here, and from the input image, we will be extracting patches which are of sizes 7x7. And then we will do, as I told before, that we will be doing data augmentation. So data augmentation means like we will be resoluting the resolution means we will do resolution of the images in various scales, because it is multi-scaling. So we will be resoluting them in various scales like 9x9, 11x11, and 13x13. And each of these resolutions we will pass through convolution neural networks. Now, as we can see in this figure very clearly, that the convolution neural networks which we are using, there are actually four blocks we will be using. Okay, and then we will have the max pool, which I will discuss after some time. So first, in the four blocks which we are each of the first three blocks, the size of the filter which we used is 3x3, and the last block means the convolution 4, as we can see, the size of the filter will be 1x1. And the number of filters for the first two blocks are 4 and 8, as we can see for each of the resolutions. And for the last two blocks, the number of filters are 12 and 12. Then the output, as we know that in convolution neural network, what happens is there is the input layer, there is the output layer, and in between there is the hidden layer. And this hidden layer contains actually first the convolution part, then the activation function, and then the max pooling function. So we will use ReLU actually over here, and after that means whatever output comes out from convolution layer 4, we will be feeding them into the max pool. Okay, we will do max pooling. Max pooling means actually you have to if there are some if there are values, you have to extract the maximum value, and we will be doing 2x2 max pooling over here. Means suppose the whatever may be the size, the final size of the vector will be 2x2. So for each of these resolutions, we will do the max pooling, and we will get 2x2 size images, and then we will pass the images to the flatten layer. The flatten layer means it will reduce the dimension to 1x1, means it will reduce the dimension to 1x1, and then the output will be fed to the dense layers. Now dense layer 10, 50 and 10, 50 and 100, as we can see here. So each of these dense layers means that suppose dense layer 100 means there will be 100 neurons, and so on. For 10 dense layer 10 means there will be 10 neurons, like this. And then finally whatever output that will be, we will get from the dense layer, last dense layer, that will be classified. Like for example, class 0 or background means this particular cell will have no nucleus, and class 1 or nuclei class means this particular cell will have nucleus. So this is whatever I had to speak about the overall architecture. And then we have the dataset description. In dataset description, we have used ISBI 2014 overlapping cervical cytology image segmentation challenge dataset. Now there are, as we know that in deep learning always there is the training set as well as the test set. So we will have this data set comprised of 45 synthetic cervical cytology grayscale images and 16 extended depth field EDF's real cervical cytology images. Synthetic cervical cytology means those cells which are actually not real cells, they are false cells, means just used for experimental purpose. And EDF means the real cervical cytology cells which will be used, and the size will be 512 cross 512. That will be used for training. And for testing purpose, we will use 90 synthetic images for the testing purpose. And then we have the results. As we can see that this is means for example, in the left hand corner, we have seen whatever cells are there, they are maybe in segregate, or they may be in clumps, but the ground truth and the means final images, they are more or less matching. Means when we do convolution and all the other processes, we will find that the final output which we are getting, it will be tallying with the ground truth. And then this, here comes the qualitative evaluation. The above figure shows that some of the sample test images from our data set corresponding nuclei annonation and the nuclei segmented by our proposed model. Further, we can see that even highly clustered nuclei colonies are also segmented accurately. Thus, we can say that our framework is robust and can be used for nuclear segmentation from pap smear images. So then we conclude that segmentation of overlapping cervical cells is a significant challenge in medical history. Nuclei segmentation is necessary prior to cervical segmentation. However, the presence of outlines like bat stains, mucus, blood, inflammatory substances, false nuclei makes nuclei detection a difficult task to accomplish. Thus, in this work, we have designed PapNet, which means a patch-based multi-scale deep learning framework for nuclear segmentation from pap smear images. The evaluation justified our claim that the proposed framework is robust and can be used for automated nuclear segmentation in pap smear images. As a part of our future work, the segmented nucleus will serve as seed for cytoplasm segmentation. So these are the references from which we got our data. So thank you.
So thank you so much for the nice presentation. But you see, can you just move back to your reference section?
Yes,
Just
sir.
share the
Sure.
screen once
Yes,
again.
sir. Yes, sir. I'm trying to do it once.
So I can see here that
This is
first
my
of all,
first presentation, so actually I'm little bit
yeah, it's okay.
nervous.
But the refer, whatever articles you have referred here, this is old first of all, and you
Okay.
can see in the reference, the
Yes, sir.
first reference is incomplete actually. So you have not
Yes, sir.
written whether it's a journal paper or somewhere it is published in the
Okay,
conference.
okay, okay,
So,
okay.
please take care in the next
Yes, sir.
presentation.
Sure.
Anyway, it's a nice piece of work, but go back to your result sections. It will really
Yes, sir.
benefit
Sure,
to the
sure, sure. Yes,
society.
sir.
So
Yes.
just go back. So this is only your results.
Sir, actually, we are still means improving on it. Means not yet fully completed. Actually, whatever work we have done, actually, we have presented on basis of that. We are still working on that.
What about the validations, that how whenever you are segmenting,
Yes, sir.
uh, is it correct? Is it correct or not? How you have validated these things?
So that portion actually I have not mentioned in the slide. That is the quantitative evaluation. So means that portion I means due to shortage of time I have not mentioned. There are actually two
Acha.
factors, that is precision and recall. And based on the means values we will get for precision and recall, we will be validating that whether this is means segmenting the cells properly or not based on the precision and the means recall values.
Yes, yes. That part I was asking actually. So
Yes, sir.
if
Precision
you,
and recall values, that is necessary, sir. Based
that
on
is
that
that is
only.
there in your presentation, right? In your paper.
Yeah, that is paper. It is there, but in the presentation, I just forgot to actually mention that part.
Acha, these images are open data set, or it's you have collected from somewhere?
Sir, it is from open data set.
It's open data. I think it was challenge, na? Some challenge, right?
Yes,
Or
sir. Yes, sir. Yes, sir.
it's okay, okay, okay. Anyway, it's okay.
And
So
so
now,
that thing which I mentioned, actually, my corresponding author actually told me to mention that thing. So based on what she said me, I just told that means
okay, okay,
the resubmission part. Okay.
okay. But you could have included those things. I
Yes,
would
sir.
like to,
Sure,
I
sure.
would like to, request Dr. Ghosh to please continue.
Yes. Ms. Bakshi, I think you have
Yes,
done
sir.
a fabulous job for your first time. Don't worry.
Yes, sir.
Uh,
Yes, sir. Hello.
yes. Can you hear me?
Yes, sir. Little bit hazy. Yes, sir.
Yeah. I think you have done a good job for the first time. But
Thank you.
So I have a couple of questions regarding the
Yes, sir.
architecture. Can you go to that
Yes,
page?
yes, sir. Sure.
Okay, here. Uh,
Yes, sir.
Question number one is what is the dimension of the input image?
What is the?
Dimensions of the input image.
So 7 cross 7 means we are extracting
No,
patches for
the
the.
original image. The original image.
Sir, original image means it was. I just can't recollect right now. Original image it was like 100 cross 100 or something like that. I
Okay,
just
okay,
can't recollect right now.
okay. So after
100
clicking
cross
on
100
cell,
something like that. Yes.
fine, fine.
Hmm.
Another thing is in the convolutional layers, are you using any padding?
So ReLU pad means we have used sir actually one activation function. Okay, means
No, but
then activation.
padding
Yes.
factor have you included? There is a
Sir,
factor
ReLU
called
padding.
padding.
Yes, sir. ReLU padding. Just have to we'll see that part actually once again. Padding I've used, sir. Means I just can't recollect right now, but padding I've used.
And in the flattened layer, can
Yes,
you
sir.
tell me what is the number of neurons after reaching the flattened layer?
Sir, it will actually reduce it to 1 cross 1. Means one row it will reduce.
No,
It will
that I
reduce the
understand,
entire
but
dimension into 1
just
cross 1.
like the dense layer has 100 neurons,
Yes,
previous
sir.
to that, how many input features are you can get in the flattened layer?
Sir, 50. 50.
50. Before
50.
100, before 100 there are 50 values, right?
50, 50, sir. 50. No, sir. 250. 250. 250. Sorry. 250. 250.
It's not adding up actually, because if you have 12 2 cross 2 features,
Yes,
that
sir.
would be 48 features. 48 into 4, that would be something around 192. Should not be 250.
So 250, as far as I can recollect, it is 250, sir.
Please look into those, clarify those things, okay? And
Okay, sir.
also, I think padding is a this. I am asking about
Padding
padding.
I've used, but just right now I cannot just
Yes.
recollect that part. Padding I've used.
I'm
Relu
the
padding
reason.
I've used.
The
Relu
reason
padding I've used.
ReLU is the activation function. Padding is
Activation.
separate.
Sorry. Yes, sir.
Um, just listen to me. The padding I'm asking is because if you are using 7 cross 7 input images, and
Okay.
if you are doing 4 consecutive convolution operations, the image itself will be coming down to 1 cross 1 if you have not used padding. And
Okay.
after that, you cannot do a 2 cross 2 match. Okay, so that has to be justified. That
Okay,
was
sir.
missing. Okay.
Okay,
And
sir. Okay,
also
sir.
the numeric result, the quantitative result is essential. Try to
Okay, sir.
keep
Quantitative
that in
part.
each operations. But I think it's a good job. Very
Okay, sir. Yes.
discussed.
I think she left. Okay, let us thank the speaker. Thank you for the nice presentation. Now our next presenter, I think paper number 105 and Al 106, right? So an ultra thin multifunctional polarization converting meta surface with wide angular stability. Okay, our next speaker is Miss Soma Hazra. So I'd like to tell her to kindly present your paper. So
Good afternoon, everyone. Am I audible?
Yes, yes, you are right.
Hello. Okay, I'm just going to share my screen, sir. One second.
yes, please. Uh,
Is it visible, sir? Hello. Okay. Um, so good afternoon, everyone. I am Shoma Hatra. I am the research scholar of University of Calcutta. Today I am going to present my paper named as the pre-processing aided deep transfer learning model for the human object detection in the crowded scenario. So my paper number is 106, and this is the outline of the presentation. That is started with the introduction, motivation, followed by the proposed methodology, resultant discussion, and conclusion and the references. So, as we all know, whenever we are moving in some crowded places or some public areas, I hope we all have seen that multiple CCTV cameras are already placed there. So, in that cases, in different area, especially where we are looking for some crowded environment, so every time to monitor this particular crowd for the security reason or some another cases, we always having some kind of crowd monitoring. So in that case, the human object detection, it is also nowadays a very important task for the overall monitoring of the crowd, maybe for some crime detection or maybe for some human behavior detection or something like that. So as we all know, that is all the quality of the different cameras, they cannot be same, it can differ from each other in terms of the resolution or maybe in terms of their sizes, their orientation and all these things. So actually they are also very much having some good impact if we go for some object detection, because the if we are capturing some of the real time videos, so their resolutions and their sizing, they are not be uniform. So in that case, the successful object detection that can be interrupted. So nowadays every especially in case of the machine learning technique, we are always try to work on this particular area. And the motivation of the work, that is because if we are looking for some unconstrained object detection and the recognition of the object, so definitely we have to improve the accuracy day by day, and all those pose variations, the partial or the full occlusions, the variable backgrounds, that also interrupting all this particular procedure. So the advancement of the technology nowadays, obviously we are working on the convolution neural network in the deep learning area. So obviously it is a widely employed thing that is going to detect the object in the real time videos. And if we are going for the object detection technique, so we have a very popular two category of the technique that we all know, that is the two-stage object detection and the one-stage object detection. So if we discuss regarding the two-stage object detection technique, so basically here what is going on, we are passing the image frames, and after that it is going to extract some of the features from the given inputs, and after that some region proposals are going to be generated, and after that we go to the localization, regression and classification technique, and at the end we have the detected object with their corresponding bounding boxes, and also we have the corresponding object score according to their classes. And if we and but this particular process is somehow little bit slower to generate the ultimate intended output. So if we go for the one stage object detection technique to overcome this particular problem, so that is here we actually mainly following the on stage nowadays. It is very useful nowadays also because it is very faster, and there is no region proposals are directly going to be generated. Instead of that, this whenever we are passing the input frames, the objects are going to be generated by the object feature extractor module, and especially by forming the feature pyramids. So the input image can be uniformly sampled here and also going to be classified very well. In our work, uh, we are just going to implement a particular framework through which the object detection is going to be possible. But the thing is that before that we are going to pre-process all those images, so that it is going to be visible that without the pre-processing and with the pre-processing, what are the changes we have got. Basically, in our work we have used one two-stage method and two one-stage deep learning modules to detect all those objects and got our intended output. So this is the proposed methodology. This is the workflow of this particular module, where we are just going to extract the video frames from the given input, and then we are passing it not only directly to the object detection module. Instead of that, priorly we are going all these things, it is going to be gone through the pre-processing module itself, where we have mentioned the scaling, normalization and data augmentation technique. And after that, whatever the output is going to be generated from this pre-processing module, after that it is directly going to the object detection by using the deep learning models. So the basic idea of this structure is mainly focusing on the pre-processing module, after the object detection techniques, including the transfer learning methods. So if we are considering the pre-processing technique, lots of parameters are there, but in our work we have included mainly three parameters, that is scaling, normalization, and data augmentation. And the scaling that we have implemented here, that is basically depends upon the bilinear interpolation method, and it is a resampling method that use the distance weighted average of the four nearest pixel values to estimate a new pixel value. And this particular scaling is going to be scaled by the 640 by 640, so that we can get this particular uniform scaling. And after that, that particular thing is also going to the next phase, that is the normalization. And the resolution of those captured video frames are varies in most of the circumstances, as I have already discussed before. So that could be also giving some effect in our result. So to overcome this kind of problem, we have implemented the min max normalization technique, which performs a linear transformation on the original data. And the technique also gets all the scaled data in the range of 0 1. So the um, min max normalization technique we have implemented, and after that the normalized data we have got. After that, actually we are mainly try to focus on the real-time crowded video. So in that case, if we are dealing with mainly the human object detection techniques, so basically the good data sets, they are the constraint factor maximum time. Because if we are dealing with a real-time crowded video, so we can have multiple issues, just like the occlusions, just like the different backgrounds, or the day or night videos, that say all can be differ from each other, and also different kind of factors also responsible in that area. So we can have the problem of the underfitting or overfitting, just the lack of the proper data sets. So if we go for the data augmentation technique, where we have the constant data set problem, so we can overcome somehow this particular issue. So in my work, I have implemented the mix up approach. That is, in this particular approach, we have utilized this particular data augmentation technique, that randomly select two samples from the training images, and after that it is going to perform the random weighted summation, and then label of the samples are also going to correspond to the weighted summation. So in that case, we can see this particular inclusion of this particular mix up technique, the mixed images in this particular training data is also going to reduce the training time, as well as we can get the better result. So after this particular scaling, normalization, and data augmentation, so this is the particular sample output, where I have just going to give you the output regarding the scaling and normalization. This is the input and this is the output after the scaling and normalized format. And after this particular preprocessing technique, we have gone through the object detection module. In my work, I have considered one two-stage technique and two one-stage technique, because nowadays the one-stage technique is actually widely used, just because it is also very fast, and as well as giving a very good output. So in this particular area, the faster RCNN, yellow feature, and yellow 5, three of the modules I have used, that is a pre-trained module. We all know that is the faster RCNN is also the model for the object detection, and the yellow v3 and yellow v5, that is the one stage detection technique, and it is the yellow v3 that is trained on the ImageNet, and yellow v5 it is trained on the Coco data set. And in the yellow v3 as a backbone, the darknet 53 is going to be used for the feature extraction module, and yellow v5 we have used the particular, in this particular module, the CSP darknet 53 is used for the feature extraction, and the for this particular backbone, as a backbone. And the next section we have used the PANET, that is a feature pyramid, that is for the good scaling, object scaling for the generalization, object scaling generalization technique. And then lastly, all this particular pre-trained module we have already worked with, that they are also gone through this particular transfer learning process, because all those particular primarily that I have discussed, these three of them, they are actually going for the multi-class object detection. So our main focus is to detect the humans, that's why human objects, that's why the transfer learning technique we have employed, where it is a machine learning technique. We all know that is, it can allow a model that is developed for some work and can be used for some another task also, as per our intention. So in that case, we fine tune this particular models, and for the given particular transfer learning, we have used the data set, this one, that is the YDFS data set, and it is a very good benchmark data set for the face detection of the humans, and it is around 32,000 images, labeled images. So by using this particular wider face data set, we have taken 70% for the training, and rest of the section is for the testing sections. And when we have gone through the transfer learning technique, after that we have got the result, that is the output with preprocessing and without the preprocessing. And when we have tested, we have got the result like that, that is by using the faster RCNA, that is two-stage object detection without the preprocessing. When we have tested by using this particular white face data sets, the precision recall and MAP, we have got this one. And after the preprocessing technique, what we have got the better result than before. And if we go, this is a two-stage method, and if we go the same thing, if we are implementing on the yellow v3 and yellow v5, so yellow v3 without the preprocessing, the precision we have got 82.45%, and MEP that we have got 85.6. And same thing is going to be implemented after the preprocessing if we are going into that. So then we have got the precision 86.4, and after that the MEP we have increased by 91.1. And the next one, that is yellow v5, that is 84.2 for the precision we have got without the preprocessing technique. And with the preprocessing, if we are implementing that part, we have got the precision level 91.4 and the MEP 96.8. So significant difference we have, that is visible in front of us. So that is the effect of the preprocessing. And this is the overall comparative study in between all these particular three model. So 80 the first are RCN and yellow v3 and yellow v5. So among all these things, that can be, we can say that in the crowded scenario, the yellow v5 is giving us a better result. And if the same thing is going to be done after the reprocessing technique, then we can get some more better result. So at the end, we can conclude that this particular work is actually represents transfer learning based on the deep learning methods for the human detection technique. And it is also going to tell us that if we want to improve the accuracy, especially for the real-time crowded scenarios, so the pre-processing actually giving a good emphasis for this particular object detection technique. And more parameters can also be there. And just I said the different weather, that is also varies, the camera qualities also differs, occlusions full and partial both can be there. So different parameters are there. So we are still working on it to implement more features in the pre-processing module. And it for the constraint of the machinery issues and the labs, obviously I have just implemented all these things in techniques by using only 20 epochs. So if I raise the number of epochs, so I hope we can got a very good result. And we are still working on it. And mainly we want to focusing on the pre-processing technique, so that if we go to the pre-processing before the object detection module, so that we can get very good result in also in case of the unconstrained object detection technique can be generated. These are the main references of the work. And thank you.
So thank you very much for the nice presentations. Now I would like to invite Dr. Swarnendu Ghosh to give his comments.
Hello, am I audible?
Yes, sir.
One thing I would like to ask you, do you have any output of the detected objects from the images? The output images? The bounding boxes?
Yes, sir. I have not incorporated that part in the paper.
Can you tell me where is it failing? Where is the network failing? In which cases?
Sorry, sir.
In which cases is the network, like the YOLO algorithm is not performing? Like what are the objects it cannot detect? Can you tell me?
So yellow is actually detecting multi-class object detection. It is different classes. It can
No,
sorry, sir. I don't know.
my point
Yes.
is in which images it cannot perform. From the output images you must have seen, in some cases it might not be able to generate the bounding box. So could you recognize in which cases it is failing?
In my work, Acha, you were asking about the in this particular human crowd where it is going to
Yes,
fail.
yes, yes.
Yeah, actually, sir, maximum cases, if the face is mainly in my work, I have tasted in some area where the images they are not going to be recognized, especially if the full occlusion or maybe the 75% occlusion is there. So the occlusion part is also there where we need to work so that that can also be visible. And if it, it's a if the light is very low, it's a kind of very dark side, so then also this is not going to be recognized very well.
Okay, okay.
And,
No
and
question from me. Thank you.
Uh, is there any questions from the audience? So if there is no questions, let me thank the speaker. Thank you for your
thank
presentation.
you, sir.
Thank you.
Thank you,
Thank
sir.
you. So our next presenter is, paper ID 108, multivariant statistical tool and subcomputing methodology based hybrid model for classification and characterization of each data. Presenter is Shreyasi Datta. Shreyasi, please continue with your presentation.
Hello. Hello, am I audible?
Yes, yes, audible.
Thank you. So let me share my screen. Hello. Hello.
Yes, yes, you are audible. Please continue.
Is my screen sir visible?
Yes, yes, visible. Please continue.
So my paper ID. Good afternoon, everybody. My paper ID is 108. It's a multivariate statistical tools and subcomputing methodology based hybrid model for classification and characterization of East data. Myself, Shreyasi Datta. I am from Jalpaiguri Government Engineering College, West Bengal, India. And with my co-author, I am like to thank my co-author, Dr. J. Pal Chaudhary. He is from Narula Institute of Technology, Kolkata, West Bengal, India. So, pharmacological data set. Pharmacology is a biomedical discipline that focuses on the investigation, discovery, and characterization of substances with biological effect, as well as the understanding of cellular and organ function in connection to these chemicals. Drug composition and characteristics, synthesis and drug design, and molecular and cellular mechanism are also covered in this field. In a nutshell, pharmacological study is concerned with how medicines affect the body and how the body reacts to them. Because of its widespread use in pharmaceuticals, it is known to be have uh, pharmacological properties. So the data set, which was downloaded from UCI laboratories, was chosen for its therapeutic potential in pharmacological research in this investigation. So here, what we have done, we have proposed a hybrid model, which is consist of factor analysis, some statistical tools like factor analysis, distance vector algorithm, and principal component analysis, along with fuzzy time series model, artificial neural network, and genetic algorithm. We have done residual analysis in throughout the steps and compared the result and concluded with some result. So this is my dataset description. I have downloaded the dataset from UCI. The dataset consists of 8 attributes. On the basis of the attribute values, the output is classified into 10 classes. There is no missing value for attributes, and it contains a total of 1484 number of instances. So this is the details of residual analysis, which is comprises of absolute residual, sum of absolute residual, mean relative error, mean absolute residual, standard deviation, and average error. So this is my implementation part. I'm coming directly to the implementation part, and my implementation is broadly classified into following steps. The first step is comprises of the application of factor analysis algorithm, principal component analysis algorithm, and distance vector algorithm. These three algorithm we have uh, applied to each dataset separately to compute the total effect, that is the cumulative effect of each of the sample. That is for each sample we have computed one single value, and this from this after that from the first step we have applied also residual analysis, and from these three algorithm result of one algorithm have been chosen. And in our study here, the result of factor analysis algorithm was chosen because it gives the minimum average error. After that application of fuzzy time series model, we have applied the fuzzy time series model. That was a model chosen and introduced by Song and Chisholm in their famous paper, and and we have applied that model in the cumulative effect value, and again also residual analysis have been done. After that, we have applied feed-forward artificial neural network model. What we have done, we have applied the ANN model on the results that we have get from fuzzy time series method. So again, we have applied residual analysis, and then we have applied genetic algorithm. That is also we have applied on the result that we have got from the step 3. That is the results we have got from feed-forward neural network model, and on that results we have applied genetic algorithm, and we have also done some error analysis and concluded, and the result also have been shown in my slides. So this is the steps for factor analysis, and for factor analysis I am not going to the details of these steps. So this is some of my results. That is in factor analysis what we have done. We have calculated the eigenvalue of each of the attributes. We have I have also said previously that we have 8 attributes, and we have computed eigenvalue of each of the attributes, percentage of contribution of eigenvalues, and with the help of this eigenvalue and this percentage of contribution, we have calculated the cumulative contribution of eigenvectors for eigenvalues. Okay, and with this cumulative contribution, what we have done, we have formulated one thing, that is for formulation of the total effect. The formulation has been shown in my slide. The total effect equals to, that is the cumulative contribution part, and the multiplication of value for that specific attribute, and each of them are being added to computed our total effect value. So using that relation, the relation that has been displayed in my slide, the total effect has been computed for each sample of each dataset. So we have this is what I have shown up to this. The total effect that has the steps for the total effect that has been done for computing the total effect on the factor analysis part. So likewise, the total effect also has been computed by using principal component analysis and distance vector algorithm. I am not showing that part because it will be than my presentation. And after that, what we have done, we have done the residual analysis on the results, and the results shown that factor analysis results gives the minimum average error. So we have selected the average factor analysis results, that is the cumulative effect or total effect that have been computed by using factor analysis, that is being chosen for our next further study. So our further study, that is the step 2, is the application of fuzzy time series method. So fuzzy time series method has been time constant fuzzy time series model inspired by the model proposed by Song and Chisholm has been applied on the cumulative effect obtained from factor analysis. So here the step by step of factor FTS model has been described. So first we have chosen the universe of discourse, and after that the cumulative effect obtained from factor analysis is fuzzified based on Gaussian membership function, and after that using the symbols proposed by Song and Chisholm, fuzzy logical relationship has been computed, and with this logical relationship, a cumulative sum value has been obtained, that has been displayed in my slide. And with this value r, that is the cumulative sum, we have also computed the predicted fuzzy output membership value. So the predicted fuzzy output membership value is a fuzzy value. So we have also done the defuzzification. For defuzzification, we have what we have done. We have applied a modified centroid method. That is a centroid method. That is the actual the basic centroid method was not given. That is we all know was not given is not given a good result. So we have done some modification of the centroid method. The modified centroid method is also given, and with this modified centroid method, we have defuzzified all the values, all the fuzzy membership values. So this is a sample output, that is a screenshot actually. That is a total effect value with their input fuzzy that we have calculated. After that, the output fuzzy membership, that's displayed in column 5, and their defuzzified value is also given. So with this, we have likewise here only 5 samples. All the things for only 5 samples has been given. We have done the total things for all of the samples, and we have calculated the total effect that has already been calculated actually. After that, the defuzzified values. So by this, as we have a total effect values and their defuzzified values, so we again also again applied residual analysis, and the average error is given as 12.017. So that was, we are okay with this. And after that, what we have done, we have applied we are coming to the part 3 part, that is the application of feed forward artificial neural network. A feed-forward artificial neural network with backpropagation training algorithm has been applied on the forecasted fuzzy output of fuzzy time series model. The inputs are forecasted fuzzy outputs, and the outputs are also of fuzzy set type. So the output obtained from this step is again defuzzified using the modified centroid method. So the input was fuzzy and the output was also fuzzy type. So again the defuzzification have to be done with the results of the result that was obtained from by applying artificial neural network, and we have done that. And the defuzzification was also done by using modified centroid method that have been already that have already been discussed previously. After that, the residual analysis have been done, and the residual analysis that we have got is gives us the average error is 50.93. That is not at all satisfactory, but it was a trial method. So what we have done is we have also displayed this average error here. After that, we have applied genetic algorithm. So what we genetic algorithm, we know the steps, that is the some random population have to be generated, the fitness function have to be calculated, and we have applied mutation and crossover to get the output. So, and when after mutation, we again after genetic algorithm process, what we have done, we have again applied residual analysis, and here we have seen the residual analysis. In the residual analysis part, average error comes to 7.407. That was quite satisfactory to us. So so here it is concluded that the application of artificial neural network on fuzzy time series model was not, the result was not satisfactory at all. But when we applied genetic algorithm on the results that we have obtained from ANN, it gives a quite a satisfactory result. So this is the comparison, and we can see that the part, there is the third column, that is where the results, where the outputs are of the outputs are of the model, the hybrid model that we have proposed by applying fuzzy time series, artificial neural network, and genetic algorithm on the total effects computed, gives us some satisfactory result. Obviously, when we apply on FTS and ANN, both the result were not satisfactory. But when we apply genetic algorithm on the results that is obtained from FTS and ANN, gives us some satisfactory result. So that the slide I have already discussed about it. So this is my conclusion part. I am concluding that we can apply different model. So this hybrid model gives us as some satisfactory result. So this model can be applied on some different pharmacological data sets, and obviously this model can also be tested or tried with some. We can also apply some different subcomputing models also in this hybrid model to check whether that will give a good result or not. Thank you.
Thank you for the nice presentation. So I just want to know whether please don't stop sharing the screen. Please open the screen once again.
Yes, sir.
So there is no reference, I think, in your presentation, right? You should have mentioned those reference. And I just want to know that why you have chosen this hybrid model, genetic algorithms and all. Okay, so why you have chosen? Is there any justification?
Sir, first of all, this is my actually this is the references should be there. My paper have references, but I have missed that part. I am very sorry for that. I can see show you the references here also, and
No,
but this is not
it's
included
okay.
in my slide. So that is, I'm
Okay.
very sorry for that. And the second part is
So
that we have the hybrid model that we have proposed. It was of using factor analysis and different subcomputing methodologies. What was that? We have also tested is data on IST and other pharmacological data set also on the other different subcomputing model like we have applied Firefly algorithm. We have also applied
telling that
TSO.
you why I am telling that, whether theoretical background you have studied, because whatever result you are showing, that depends on the dataset basis. It varies on the basis of dataset and dataset. So you should have a solid justification that why should I use, at least theoretically, that why should I use these two hybrid techniques. Another thing is that whenever you are using some hybrid techniques, obviously the complexity will be much higher. So the cost involved also, apart from the this accuracy, the cost involved also, you have to see that there is a balance between the cost involved along with the accuracy. So these two things, have you done it? And if you have done it, can you justify it?
No, sir, I am not. I'm not considering the cost part actually. What I have done, I have tried and tested different subcomputing methodologies, and this type of hybrid model gives us the good result. Yes, this model is totally data dependent. I should. I'm accepting the fact.
Okay, so thank you very much. Okay, I think Dr. Ghosh can continue, please.
No questions from me. Please proceed. No questions, sir. Please proceed. Hello.
Hello.
Am I audible, bro? Sir, am I audible?
Oh, if there
Hello.
is no more questions, let me thank the speaker. So thank you very much for the nice presentation and wish you all the best. So our next presenter will be paper number 111, performance evaluation of different deep learning models for breast cancer detection in mammogram. And the presenter is Mr. Jayanto Das. Jayanto, please continue with your presentation. Please.
Exactly, sir. So in this case, uh, me Joanto Das. Acha, is this paper is shared perfectly?
Yes,
That is
yes,
the
it's there
purpose.
perfectly, but make it full screen. Yeah,
Exactly.
slide. Yes, yes.
Slideshow. Okay.
Yes, yes, that's done.
So,
Please move
so
on.
am I audible, sir?
Yes, yes, yes. It's audible, properly audible.
Okay.
Please
So
move
very
on.
good afternoon to all the dignitaries. So in this case, my paper is the performance evaluation of the different deep learning models for breast cancer detection in mammogram. So in this case, though I present, but before this, I am very grateful to Sir Professor Dr. Debotosh Bhattacharya, Jadavpur University, and Dr. Saurabh Pramanik, the Assistant Professor of the New Orleans. So in this case, so me, Jayanto Das, Assistant Professor of the NSHM Knowledge Campus. Okay. So this is the content. So introduction, contribution of the paper, flowchart, methodology, result, and conclusion, and the reference. So in this case, introduction. So in this case, the cancer is expected to serve the main cause of the death. Among all the cancers, that is the breast cancer is treated as the most common cancer in case of the woman. But that does not mean it is not happen in case of men. Okay, it can be happen, but in this case, it is the most common case with respect of women. Okay, so in this case, the most commonly diagnostic tools in this case mammography. So mammography, involves the applying the low energy X-rays for examining the breast for any suspicious malignancies. Okay, malignancies. So in this case, now I have to discuss the contribution of the paper. So in this case, the comparative study of the deep learning models. In this case, exception, DenseNet 201 and the DenseNet 152 has been performed to detect the breast cancer in mammogram. So regarding this matter, an extensive experimentation has been conducted on 3 different datasets, such as the DDSM, MIS, and the INBS, to evaluate the performance of the above said deep learning models. So this is the flow chart. That is the start. That is the collect the DDSM, MIS, and the INBS data set from the various data sources. So in this case, my sources is the data.mendeley.com datasets. So after that, apply these 3 the networking model exception, DenseNet 201 and the ResNet 152 with respect of the above mentioned dataset. Now after that, calculate the accuracy as well as the AUC. With respect of this accuracy and the AUC, we have to compare all these things with respect of the different models. Here, these models is the exception, DenseNet 201 and the ResNet 152. Now, in this case, we have to implement it. Now we have to discuss, we'll discuss all these things one by one, these 3 network models. That is the exception, DenseNet 1 and the ResNet 152. So in this case, the exception in main difference, it is the extreme inception architecture. It is the main concept in this case. It is the main concept, which is the unique with respect of, which is differentiated from the inception model. This unique features in this case, the depth-wise separable convolutions. We know in this case, the depth-wise separable convolution, in this case, the convolution is applied at the one channel at a time. But in case of the, unlike this exception, in case of the inception model, the normal convolution method is implemented. In this case, the convolution is applied, and in this case, at the m number of channels, okay, at a time. So in this case, whatever it may be, whatever the cost consumption is too less in case of the exception than the inceptions. This is so that in this case, we choose the exception model, So this is the overall architecture of the exception model. Now, in this case, there are different hyperparameters just used with respect of this. That is the binary cross entropy, initial learning rate, and batch size, that is the 32, number of epoch 52, and the optimizer is the adder. So now, once we complete the discussion of the exception model, next is the DenseNet 201. So in this case, there are some features which is unique with respect of the DenseNet 201. So in this case, the strong gradient flow. Strong gradient flow means that is the, in this case, that is the last phase. The error signals should be propagated from the very last phase to the all previous phases, so that the all previous phase should be aware with respect of the, as well as the last phase should be aware to the error signals. In this case, the more diversified features in the DenseNet in this case. Suppose in this case, in terms of the parameters, so in this case, if we compare this DenseNet 201 with the ResNet model, that is in case of the number of parameters, in case of the ResNet is too higher than in case of the DenseNet. So that in this case, whatever it may be, the computational cost should be lower, in case of the DenseNet than the ResNet. And another thing, another one unique features of the DenseNet 201, in this case, the classifier uses the all complexity models. So in this case, because classifier uses the all complexity levels, in this case, at that time, whatever the decision boundary or whatever, it should be so smooth and accuracy should be improved. And this is the architecture of the DenseNet 201 model. And now all these hyperparameters, same in this case, the loss function, initial learning rate, batch size, and number of people, and the optimizer is added. Now in this case, after completion of after discussion of the DenseNet 201, now we have to discuss the ResNet 152 features. In this case, ResNet that is in this case, it is the micro architecture. One of the unique micro architecture is implemented with respect to ResNet. In this case, micro architecture means that is the connection between the network to network, and in this case, that is for constructing the network. So in this case, in all this micro architecture should be formed finally the one macro architecture. That is it is the end of the network. So in this case, that is why it is the residual learning unit structure is designated as a feed-forward network. Feed-forward network, whatever it means, in this way, it is proceeded. That is all the micro architecture, in this case, finally the one macro architecture. So in this case, whatever it may be, the residual learning units architecture is designated as a feed-forward network. This network associated with a shortcut connection is able to add the new inputs into the network. Finally, this network generates a new output. Obviously, in this case, the main advantage in this case to produce the better classification accuracy. But in this case, at the same time, it has been observed that the complexity of the model is not increased. So this is the model. This is the diagram of the ResNet 152 model. Now the hyperparameters, all these loss functions, initial learning rate, batch size, and the number of people, and the finally optimizer. So now the result in this case, we just use the two types of result. One in this case, that is the DDSM MIS iron based, that is the training and testing. In this case, suppose in case of the DDSM, both the DDSM and the DDS, in this case, the DDSM is implemented as a training as well as the testing part. Okay. So in this case, it has been seen the accuracy is the 0.8072 and AUC this, and with respect to this is the DenseNet 201, and with respect of ResNet 152, it is the accuracy and the AUC. With respect of the exception model, this is the accuracy and the AUC, that is the area under curve. But in this case, in terms of when we reach at the next model, that is the MIS, the accuracy and AUC is, in this case, accuracy is too improved with respect of in compared to the DDSM, but AUC is far lower. And this is in this case, the model is the DenseNet 201. In case of the ResNet 152, this is the 7695, and the AUC is the 0.529. And in case of the exception, it is the 0.9374 and the 0.785. Next, we go to the iron-based data set with respect of the DenseNet, ResNet, and the exception. In case of the iron-based data set, in this case, it has been observed that accuracy with respect of the all three models, that is the DenseNet 201, ResNet 152, and the exception, is far better than the previous data set. Previous data set, in this case, DDSM and the MIS. Okay. And this is the AUC of the iron breast, that is the 0.513. In case of the ResNet 152, that is the 0.527, and in case of the exception, it is the 0.539. Okay. Now, this is the inter-dataset performance evaluations. Now, we just apply another thing to store that, to display the result with respect of the another parameter. This parameter is the inter-dataset performance evaluation. In previous case, we just choose or we just select the DDSM dataset in case of the both training and training phase, MIS in case of both training and testing phase, same case with respect of iron base. But in this case, in this inter-dataset performance evaluations, in this case, it is the something different. In this case, training in first case, the combination of the DDSM and MIS and the testing is the iron breast. Okay, that is the accuracy in the 0.8607 with respect of DenseNet 201, and with respect of the ResNet 152, it is the 0.6738, and with respect of exception, it is the 0.8350, and accuracy and AUC in this case, it is the 0.535, 0.489, and the 0.4669 respectively. Next, we have to go to the next, that is the combination, in this case, the training, that is the DDSM and the iron breast. But testing dataset is chosen as the MIS. So in this case, it has been observed that is the DenseNet 201, it is the 0.9169, and in case of the ResNet 152, in this case 0.8486, and in case of the exception, it is the 0.8759, and AUC is the 0.491, 0.461, and 0.534 with respect of DenseNet 201, ResNet 152, and the exception respectively. Next, we just go to the next combination with respect of the training dataset, that is the iron breast and the MIS, and the testing dataset is chosen as the DDSM. In this case, the accuracy is the 0.9424. In case of the DenseNet 201, with respect of the ResNet 152, it is the 0.9050, and in case of the exception, it is the 0.9412. And in case of the AUC, 0.582, 0.498, and the 0.539 with respect of the DenseNet 201, ResNet 152, and the exception model respectively. So in this case, the conclusion is the comparative study with respect of the 3 deep learning models, that is the exception DenseNet 201 and the ResNet 152, in differentiating the benign and the malignant mammogram has been evaluated. So in this case, we perform the inter-dataset and the inter-dataset valuation for investigating of the deep learning models performance. In future, the target is that we'll apply the ensemble learning that sees better predictive performance by combining the prediction from the multiple models for improving the accuracy further. In this case, ensemble learning, in this case, we can choose, in this case, our target in this case, say in this case, the training data set, suppose the combination of all, that is the DDSM, MIS, and the iron breast. And in case of the testing, it should be differentiated. First, with respect of training dataset should be same, but in this case, testing dataset should be differentiated. The first is the suppose iron breast, next is the MIS, and next is the last is the DDSM. In this case, it is our target for improving the accuracy. Okay, so this is the conclusion part, and these are the some reference part, reference in this case, and thank you. So in this case.
So
okay, so in this case, sir, it is my request. It is my one request, sir. In this case, I need valuable suggestion with how to improve, because it is my first.
Your slide is invisible. Slide.
Okay. Please.
It's okay now. Yeah, I can see. We can see now.
Can you see?
Yes. But don't start from beginning. It's just from current slide. Please start.
Okay.
Yes. So basically, what you have seen here, what you want to say, please explain.
So in this case, that is the comparison of the performance evaluations with respect of these three data set. That is the DDSN, MIS, and the INN based with respect of the three deep learning models. In this case,
Yes.
so in this case, I need your valuable suggestions regarding how to improve this accuracy. So in this case,
Yes.
is there any model, networking model? In this case, my knowledge is limited. In this case, this is my
So
first.
I think this is a good piece of work. So what we have done, what I have understood, that
Okay.
you have taken three different data sets and you have implemented three deep learning models:
Exactly,
DenseNet,
sir.
RaceNet, and ExceptionNet. Okay.
Exception. Okay.
So then what you have done, you have merged even those two data sets and try to find out what is the accuracy and all. So it's a
Exactly.
good piece of work. But how many? What is the image size? How many images you have used?
So in this case, in case of the dense net, we just select that 2620 images.
2620 images. Okay. So for all cases you have used, and I have seen that you have merged even the data sets and you have tested with the different other A. So it is
Yes.
basically it's a kind of experimental work you have performed, and you have tried to find out the accuracy whatever you are coming. Okay. So
Huh.
obviously you can see here the dense
Okay.
net. Dense net
Okay.
as results are deep, as it is
Huh.
having more number of layers. So obviously DenseNet will give better results. Okay. So
Huh.
what you
Yes,
can
sir.
improve, as a suggestion, what I want to say, that if you want
Exactly,
to
sir.
if you want to improve this, okay, you try to find out the cost, how much cost involved. Okay. Because
Okay, sir.
DenseNet always is very costly, and
Okay. Okay.
exception maybe a lighter model,
Okay.
and even the RaceNet also. So
But in this case, huh, sir, please continue.
pardon.
No, please continue, sir.
Okay, so you try to improve those models like RaceNet or AccessorNet. You try to improve so that you get some good accuracy with least cost. So that will be a
Okay.
suggestion from my side. You try to
Okay.
improve on it. So what you can do, you can try to go for
Huh.
that convolutions. You can go for depth-wise separable convolutions. Okay. Uh,
Okay.
okay, so which may improve the performance a little bit better. And you can changes the number of connection. You can see that somewhere unnecessarily connections are there, because these models
Okay.
are not actually for medical images. It is for some handwritten image recognition or some other
Exactly, sir.
recognition these models are built. So in
Exactly,
order
sir.
to fit your model, in
Okay.
order to fit your images in this model, you can
Okay.
change that what are the particular things in the network which is unnecessary. And if
Okay,
that
sir.
part is unnecessary, you
Okay.
can reduce that part, so that
Okay.
with least cost the performance can be improved. Okay. So
Okay.
that is a suggestion from my side. Otherwise, it is a very good piece of work, as
Many,
you
many
have.
thanks, sir. Sir, another thing I want to know, in this case, the number of epoch, I just use the 50. So in this case, is there any particular number of epoch so that it is ideal for improving the accuracy in this case?
After 50, if the graph is flattened, so I don't need to move further. Okay,
Okay.
obviously if you increase the epoch, the performance will little bit increase, but that is coming at the cost. Okay, so
Okay,
obviously
sir.
if you want to detect the the actual epoch which should be when the graph is flattened, then it's okay, you can stop. Okay.
Okay. Okay, sir.
Okay, thank you.
Many,
And
many, many thanks for your valuable suggestions.
I think I want to request Dr. Ghosh to continue, please.
Sir, I need also the sad suggestions, Dr. Ghosh.
One more thing I would suggest is to try ensemble of the three modules that you have tried.
Okay, sir.
Whatever three module you have implemented, you just
Okay.
ensemble them. Ensemble their like feature vectors, and that
Okay.
can help you with the accuracy, to improve the accuracy.
Okay, sir. So in this case, so in this case, sir already suggests the number of epoch with respect of that it is not the so in this case. So thank you, many thanks, sir, for sharing your valuable guidance, valuable suggestions.
Is there any questions from the audience? If there is no more questions, so let me thank the speaker
Okay.
for his nice presentations. Now I would like to invite our next speaker, who is paper ID 114, I think Kalpita. The paper
Yes,
title
sir.
is Challenges and Opportunities of Multilingual Natural Scene Text Recognition and its Real World Deployment. So you can proceed, please.
Okay.
Please share your screen.
Is the screen is visible, sir?
Yes, it's visible.
So, um, today, hello, sir. Today, my topic is recent challenges and opportunities of multilingual natural scene text recognition and its real-world deployment. My paper ID is 114. I am Kalpita Datuk, a PhD student from Jadavpur University at Department of Computer Science and Engineering. My co-authors are Taufik Choudhury, Professor Mohan Tapush Kundu, Professor Minta Nashikuri, and Professor Nibaran Das. My paper outlines are introduction. In the introduction, we should present application and challenges, and then we study the related work, and finally we present the proposed work and results analysis of that proposed work, and then we conclude our paper. In the introduction, text recognition, multilingual text recognition is itself is a difficult task from natural scene text images. But in case of multilingual text environment, it is more difficult than normal natural scene text images. The paper summarized the recent challenges and future opportunities of multilingual natural scene text detection and recognition tasks. Moreover, we give an overview of deep understanding of multilingual natural scene text. So we have proposed a text detection method based on MSCR-based region detection-based method, and with the combination of NE-BLACK local thresholding method, and finally we um, filtered out non-text region using the classifier to using two classifier. Here we can use, here we have used SVM and ELM classifier, but ELM performs better than other SVM classifier. Applications. Some applications of the uses of multilingual natural scene text detection and recognitions are handling transportation in an intelligent way. That means you can scan the package information, and the package information of different transportation system can recognize easily, and it can helpful for the industrial automation. It can also helpful the industrial automation, and also construction of geocoding system, which is helpful for travel and also useful for users to overcome language barriers such as automatic road sign board recognition and text language translation, and also information retrieval from the natural scene text images. Example, business card recognition and card number plate recognition is also important. And access to visual input to is helpful for visually impaired person. That means if the person is visually impaired and they can want to go the any such bank or ATM, they can use their mobile phone or Android app, mobile app, to recognize the text, and they can find the direction of the ATM or other places. And multilingual natural scene text images have many challenges. One of the challenge is important challenge is multi-orientation. In case of multilingual natural scene text, we have seen that from the left side, the third image number 3,
The third image have the multi-orientation and the skewed text, and the second and first image also have the skewed text. That means the text image is slightly angled in the different left side or right side, and also multilingual script has present in the multilingual natural text image, and also the small, large and angular text. That means you can see that here some images have different size text. That means some text have large size, font size is large, some text has font size is small, and distinct and fancy font style of multilingual text is present in our dataset. This dataset is proposed. We have proposed this dataset, and it is named as JUDVLP SI text version 1 dataset. That means multilingual natural index text database version 1. Here are some example images of our dataset. Related works, many traditional machine learning based methods and hybrid methods like combination of machine learning based method and deep learning based method have been used, and also only deep learning based method have been applied for natural syntax localization and detection tasks. So those methods have some specific drawbacks, like traditional machine learning based method means the correct choice of handcrafted features, and pre-processing and post-processing method is needed for filtering the non-text regions, and also deep learning based method needs high computation configuration. That means you should have like GPU or other RAM configuration is higher, and larger amount of training data is needed, and also execution time is larger. Hybrid method have complex merging method. That means you should apply the machine learning based method and deep learning based method. Both the method, the combination of both the method is slightly difficult in case of hybrid method. Now our proposed method is our main focus of all these past research efforts is to develop a text detection method using image and black method for binarization tasks with the ELN classifier. An input image is present here with an input image is present here. Our input image is in RGB format. Then we should convert it into the grayscale image. And then the enhanced grayscale image is enhanced input grayscale image is as put as input in the detection MSCR region based detection method, and we after finding MSCR based region then we should apply the knee-black binarization method for binary to convert the detected region into the binary format, and then we should apply some morphological operations. Here we have used erosion method, and then find the connected component analysis or connected component text, then localize the portion of using bounding box, and finally find the features of those cropped image. After localization, we have cropped our localization portion, and then we find the hog, LBP and color feature of those regions, and then we find the filter out the non-text region using SVM or ELM classifier. Here ELM has present the higher accuracy than SVM. Then final text localized region we should find. Our dataset is a description. Here JUDVLP MNSI text data version 1 database description is our dataset concentrate on various complexities such as multilingual text, skewed text like slightly left and right direction or orientation, and multi-oriented text and curved text, previously available public datasets such as ICDER 2003, ICDER 2013, ICDER 2015, and SVT dataset, they don't have such complexities like they don't have any multilingual scripts, or they don't have any carved text or multi-oriented text or skewed text. They have only font view text images, and also they have one language or one script. The dataset, our dataset contains both the localization coordinates, that means the bounding box coordinates, upper left corner of xy position of upper left corner, and height and width have present there, and also the recognized word is present. Recognized word of the corresponding text image is present as a ground truth in the JSON format. Our image contain mainly three languages: Bengali, English, Hindi. As we all know that language or script is also place dependent. That means our dataset is collected from the many places of West Bengal and Kashmir. So West Bengal generally is native language is Bengali. So most of the images is Bengali. We have total 800 multilingual natural syntax images. In that case, we have 50% Bengali, 45%, 40% Hindi, 40% English, and 10% is Hindi script present in our data set. Our dataset has also DUDVLP dataset image analysis. We have analyzed our dataset. That means some important point should be noted, that one more important thing is sometimes we need to resize our image, to enlarge or smaller than the original version of the image for requiring the training the model. So it loses some originality of the image portion, or loses some important values, whereas enlarging the size stretches the desired object and affects the specific object's property. So the multilingual natural syntax image has both the small and large text, large font size text instances. So it's better to crop the images rather than resize the images. And then next, class imbalances can a big issue in case of text detection task. When we have used machine learning based method, basically the standard classes. So choose the standard classification model is important in that purpose. Next, our results are here. So we have used MACR based region detection method, and also UTSU for binarization technique. UTSU is a global thresholding method, whereas NIBLAC is a local thresholding method. As we find all the other previous research work, and our as we experiment practically, that we find that for the natural syntax images, local thresholding is more effective than global thresholding. So we use MACRO method for SVM classifier. We can see that using ELM and SVM, is performed less than ELM, and also we should find that here that NIBLAC is better than UTSU method. Finally, in the last portion, MACR plus NIBLAC with some modification. Some modification means here when we apply NIBLAC algorithm, in that case in case of binarization our text images, one main problem occurred. That means dark on bright background and bright on dark background. Okay, sometimes the text portion is white and sometimes the text portion is black. It is affect the finding the connected component analysis. That means connected component is analyzed on the white background in white pixel images. So in that case, their result degrades. So we after knee black applying knee black algorithm, we find that the result increases. That means white pixel text pixel present on dark background, but in that case also some images present to that their text images has text pixel has black background, text pixel have black and background is white, and opposite one vice versa is present. So we should collect we should summarize the pixel of large white pixel. If the we should know that the portion of the image is 40% text and other 60% is other background image. So we find the sum of the all pixel. If the pixel is greater, white pixel is greater, then we convert the image pixel to the opposite and then find the final result. In conclusion, we have used handcrafted features like hog LPP and color features and train SVM and LM classifier to filter out the falsely detected non-text regions. MSCR has mainly drawback is that MSCR is effectively detect the text portion, all the text portion of the image, but it can also detect the huge number of non-text regions. So there should be applied some post-processing technique or some filtering technique in that case to filter out the non-text portions. So here we use SVM and ELM classifier to filter out the falsely detected non-text regions, and we achieved the satisfactory result on our proposed JUDVLP multilingual natural scene index text database version 1 dataset. Our main motive is through this paper is to chart out a route map of multilingual natural scene text recognition task by summarizing recent challenges and opportunities of the multilingual natural text detection and recognition task. Here are some references, and thank you.
So thank you very much for the nice presentation. I think it's a good piece of work in the sense what you have done here, that you have used some live data set. I think you have captured this data through
Yes.
your camera, right?
Yes,
Using your,
Android phone, mobile.
you have prepared your own data set, right?
Yes, sir.
So I just want to know, is there any noise removal techniques you have used?
We enhance the data. No, sir. Specifically, any noise removal technique I don't have used.
You have not used any noise removal techniques, no?
No.
Or you have done it?
Yes, sir. Enhancing, just enhance our.
Enhancement you have done. Okay. So then another thing is that I just want to ask why you have selected this MSER or that other segmentation techniques like OTSU and all. Is there any specific reason for it? Somewhere you have got
Yes,
it?
sir. Yes, sir. One specific reason is from studying different previous research work. I have studied and I have found that MACR is a mostly used text detection method, and after applying MACR, all the text region is detected finely, and they have some specific drawback also. That means it also select detect some non-text regions. So that's why I chose MACR and first case.
How many such images you have considered?
800 image, total 800 image.
Total 800 images. Okay. So anyway, it's nice presentation. You told about some modifications you have done. What kind of modification? I just want to know actually.
Modification, that means in case of NIBLAC algorithm, NIBLAC binarization algorithm,
ELM, right?
yes, sir. We have found that some cases text images, text region pixels are white, and some cases text region pixels are black. So how can we define the after using connected component phase method? We should find the white text region pixel and connected component of that region. So after that we have find the bounding box over there. So this is the main problem. So we modify use like using that we count all the white pixel, and if the white pixel number is greater, then we convert it into the black pixel after black binarization. We have done all this after black binarization method. So we convert it, otherwise not.
Okay. Thank you very much. It's a nice piece of work. Now I would like to request Dr. Ghosh to give his valuable comments. Dr. Ghosh, please.
Hello. Yes, Fatih, I think it's a very good presentation, and the work is quite extensive. You have your own data. You have worked with lots of different techniques. You have tried to merge them to find out your own good set of combinations. One thing I just want to clarify: when you are saying that you are doing classification, is it like a pixel level classification of text regions, or is it bounding box classification?
It is not a bounding box classification.
Okay, it's a pixel level classification, right?
Yes, sir. Yeah.
Okay. Thank you. Yes. Thank you so much. Thank you so much. Sir, over to you. I think that's the last
Okay.
one.
So is there any question from audience? Is there any question from audience? If there is no questions, so let me thank the speaker. So thank you very much for your valuable presentations. I think we reached to the end of the session. I think total, 8 numbers of papers are read, and most of the papers in the domain of this deep learning. I want to thank all of the speakers, all of the presenters for their valuable contribution, and I wish them all the best. Thank you very much. And I just want to also mention Dr. Ghosh for his valuable suggestions and the comments and his valuable time also. Thank you, Dr. Ghosh. Thank you very much.
Thank you so much. Thank you so much for everything. Really nice to meet you.
Thank you.
We now have come to the end of this